Hello, my name is Victor Hutz, and thank you for taking a moment to review my presentation. Let's get started. Of course, as you are aware, our overall assignment was to create two or more machine learning models in which the net electrical output was calculated, which will be our output metric, based on four different features that we were provided, shown here, and a data set that had around 9,500 records. Based on my lack of Python knowledge, I went ahead and decided to use Microsoft Excel with the data analysis toolkit to go ahead and build these out and solve for these problems. Essentially, the process pretty straightforward. I went through, I defined my metric, my methods, and my tools. I put everything into one workbook, which I'll show you here in a moment. And we went ahead, and each model has its own data set for training and its own data set for validation. However, of course, these are based on the same 9,500 records. About 7,000 were used for training and the remainder used for validation for each model. When I got those set up, I did the training, did the evaluation, and let's see what I came up with. So bouncing over to the spreadsheet, you'll see first, of course, we had the data, the training, the validation. And what I decided to do with the same secondary model is I went ahead and used the same function in Excel, the linest function, to go ahead and perform the test, but I also added a couple of additional columns here. You'll see I added the square of temperature and temperature times vacuum to kind of hone the models a bit, see if I got a little better performance than I did in the first one. To clarify what the linest function actually does, linest is a built-in function with the data toolkit. It basically takes the entire table and based on doing a straight linear regression, will provide the input or the coefficient outputs for each of the items. It also provides, of course, R squared and average error squared. So we can see here that my R squared and my average mean of error came up pretty good. We were looking at about a little over 1% for the 4.5 megawatts, and we found that the precision was coming in around almost 93%. When I ran the validation set, this actually did a little better, pulled the numbers in a little tighter. So it was a good sign that that initial model was working. So then I went ahead and I went over to Model 2. As I said, with Model 2, the biggest difference here was in the data itself, as I added in those extra parameters to help hopefully clear out a little bit of the error and keep things tighter. As it went through, as we trained, you can see here, I actually improved the accuracy and the size of error a bit. And one thing that really starts to become noticeable, especially in the second model, is the impact that we're seeing from temperature. The engineered didn't really have a huge impact, but they did have some that helped clean it up a bit. And one thing we can notice both times in both models is that vacuum and humidity, or I'm sorry, vacuum and pressure are basically really minimal impact here. So as I went to the validation, it also improved. Obviously, because it was running on the same data set for validation as the original model was. So that data set was obviously a bit more tuned than the core. And so we went ahead and put that together. Now, so looking at the total results, as we can see, we didn't do too badly with either, but adding the extra engineered fields did seem to help improve our results a bit. Now, as we go through, just for summing, you see we had a little better precision, a little less error impact when we went with 2. You'll also notice, as I said, temperature more impactful. If we were going to do this a bit more, I might add a couple of other engineered fields or data set fields if we have them available. Things particularly like time of day or season that were also tied into the temperature could be very informative, and we may want to eliminate humidity and pressure to see if we can simplify the overall interpretability and reduce noise. All right, that's my time. Thank you very much.